Hello everyone, welcome to another lecture of Big Data Analytics. My name is Dr. Fahimi Jafari running this session. The topic of this lecture is Apache Sqoop. Let's learn more about this topic. Let's see what we're going to learn today. Hadoop Ecosystem, Apache Sqoop, what is Apache Sqoop, and why we need a scoop. We'll learn more about the scoop commands, and I'll explain you what is a scoop metastore and a scoop merge. After this lecture, we expect all students to be able to explain a scoop and understand what is Sqoop's engine and how it works, and to be able to write the scoop commands and understand the meaning of the basic of commands, and also get familiar with advanced scoop commands like metastore and merge that we explain in this lecture. Hadoop ecosystem. You have got enough information about Hadoop ecosystem in previous lectures, but as a quick review, as you know, Hadoop is a kernel of the distributed operating system for big data. But no one only used the kernel because it's not easy to use it. Of course, we have a collection of projects at Apache on the top of Hadoop to make the life easier and using this kernel much more easier. We have a quick review here. As you know, Hadoop ecosystem include different components which support each stage of big data processing. For example, let me to show you here. For example, Sqoop and Hive ingest the data, Spark and MapReduce. You can see another library of Spark here. Spark and MapReduce process data, HDFS and HBase store data, Peak, Impala, and Hive. Analyze data. Hue help to explore data. Uzi is responsible for scheduling workloads of Hadoop jobs, and Zookeeper is responsible for coordination and management. So in this session, we focus on Sqoop. I know Sqoop and Flume both ingest data, but actually Sqoop is for structured and semi-structured data, and Flume is for unstructured data. In this session, we focus because we cannot focus on all the components. We just picked important ones. This lecture we focus on Sqoop, and in the next lecture we will focus on Peak and Hive and a quick introduction about Zookeeper and Uzi. What is a scoop? If I want to simply explain what is a scoop is the abbreviation of a school to Hadoop. It's a tool based on MapReduce, and it has been designed to transfer data between Hadoop and traditional database or relational database like MySQL, Oracle, SQL Server. So as you can see in this picture, let me show you. As you can see in this picture, we have a scoop between Hadoop and SQL. Hadoop is responsible to import and export data between traditional database that is called here a scoop and Hadoop. It is another picture that is saying the same meaning. So it's easy to do it. It's a parallel import and export tool. The main question is why we need to use a scoop. One of the main sources of generating big data is traditional management systems, which are based on the interaction of traditional application with traditional database like MySQL, SQL Server, Oracle. So if we want to analyze this big data, we need to bring them to Hadoop file system, which means, we have to be able to interact with traditional database. So it can be importing data from RDBMS to Hadoop HDFS, or it can be opposite direction, bringing back data from Hadoop HDFS to traditional database, which we call it exporting. So what is really important, we need this interaction, and Sqoop is the tool which make this interaction with RDBMS possible, and it's really easy to use. Let me to explain. Now we want to see how a Sqoop works. A Sqoop has two important tools which are called a Sqoop import and a Sqoop export. As you can guess, a Sqoop import is responsible to import data from RDBMS to HDFS. So as you know, in traditional database, all data is saved as tables. So, and we have row in tables. So when we want to import this data to HDFS, it would be each row in table would be stored as a record in HDFS. And finally, instead of table, we have text data, which can be in the shape, which can be saved as a text file or binary data. And it depends on the structure of the data. So another tool is export, Sqoop export. Of course, Sqoop export is doing the opposite way, which means export data from HDFS to traditional database or RDBMS. We have data in the shape of files and records. So when the tool wants to export this data and bring it back to traditional database, of course, records will be treated as a row, and we should have table on the other side in the traditional database. If you want to convert this record to row in the table, it's really important to have delimiters, user specified delimiters like comma, semicolon, just to make this export. So we will explain the syntax in the next slide, and of course you can understand this much better. Here is the syntax of a Sqoop import. As you can see here, you just need to write a Sqoop import. You can use a space, or you can put a dash between a Sqoop and import. And then you will have two sets of arguments, generic arguments and import arguments. Generic arguments, you can give general information for connecting to database. So in this module, we use MySQL database. So whenever we say database in traditional system, we mean MySQL. So in generic arguments, you can give you can point to the MySQL database that you're using, you're going to import from, and also you can provide login information like username and password. For import arguments, you would be able to specify the data that you want to import, which data you want, what data you want to import, and how you want to import it. So let's have a quick review on the different parameters that you can have for arguments, and also give you some examples. Then you can understand it completely. Here is two table to show you some of options you can have for general arguments and import arguments. So the first table show options for general arguments, and the second one is for import argument. So we are not going through all the parameters, and we of course just pick the important ones. So just quickly, we will explain all of these through the example, but just quickly tell you a few of them. Like the first one is connect. This is you can specify the database that you want to connect. In our case, of course, it's a MySQL database. So password and username, you can specify the login information. There are three important options for general argument. So the from the second table for import arguments, the first one is this one. The first one is append. So if you use this option, you can append data to the existing data set in HDFS. So you will have like a column, which is important. With this argument, you can select which columns you want to import to HDFS. Probably if you don't want to import all the columns of a table, then you can select them through this argument. So M is another important argument for importing. This is M or num mapper show the number of map tasks that you can use because when you want to import data to HDFS, so you will have map tasks which work in parallel to make this import. So you can specify the number of map tasks here. Usually by default it's 4, but if you want you can change it to less or more number. For a small database, okay, it's better to use less number. For example, in our case, in this example, that I explained you in the next slides, we will use 2 now because our database is not very big. So table, you can specify the name of the table that you want to import, and you have where is like a you can make a condition for this transferring, like if you don't want to transfer all records in a table and you want to transfer a part of that, you can make your condition true where. Okay, they are important ones that we will review in this lecture. Let's take an example. As you can see here, we have 3 tables: imp, imp add, and imp contact. Imp comes from employee. So, they are 3 tables of a database called UserDB. And this database is in MySQL database server. Okay, let's see how we can work with this table. Want to import a table from MySQL to HDFS. You can see the syntax here: a scoop import and table is the argument that you can specify the name of your table. In this example, we write imp. We want to import imp table to HDFS. So, and another argument is m. As I explained, m specifies the number of map tasks for importing. In this case, we wanted to import this table through 2 map tasks working in parallel. Another important argument is connect JDBC. This is the argument for connecting to your database. We are connecting to MySQL, and we are using Cloudera. That's why we write this direction, and the name of our database is UserDB. These 2 arguments, UserDB, username and password, are the login information for connecting to MySQL database. And we have as Parquet. We want this table to be transferred as Parquet file. Parquet file is an open source file format in Hadoop. It used a different technique for storing nested structures. So it stored the nested structures as flat columnar format. This is really important because it would be very efficient in terms of storage and performance. So that's why we want to be transferred as this file format. Another important argument is warehouse direction. Here, this is the location of the file that we want to be stored in the Hadoop, in the HDFS. So we are using this direction because we want to directly use Hue. I'll explain Hue later. So another argument, the last argument, is Hive import. We will use this argument if we have a Hive metastore related to our HDFS cluster. Then we need to use this argument to write this argument. I will explain you what is metastore in the following slides, and then you can understand this argument better. Okay, let's go to the next slide. Okay, I have explained this is the warehouse direction, and this is Parquet that I explained it. So, if we want to import a subset of table, so I quickly told you which argument you need to use. We need to use where and then write the condition. This is very similar to, this is exactly the SQL query that you use when you wanted to apply a condition on the set of data. For example, let's give you example, then you can understand it better. Okay, this is the previous syntax that for importing imp table. Oh, we are using imp at another table. Anyway, this is very similar to the previous syntax. The only difference here, we changed the name of table. Instead of imp, we want now to import imp add, and we have added a condition. So we want to import imp at table, but not all the records, only the records where city is equal to secpat. So the other arguments are the same as before. So as you can see the output, we are importing this table, but only those records which city is equal to secpat. This is the way to import a subset of a table, not the whole data. Okay, let's go to the next slide. Okay, in the two previous examples, we imported just one table. Now, if you want to import all tables through one command, you can do it, of course. It's very simple. You can use Sqoop import all table, or these two commands. The only difference is we have dash here, and doesn't matter if you use a space like the first line or you use dash in the second line. So through a Sqoop import all table, we can import all the table of a database from RDBMS database, traditional database, to HDFS. So, and what is really important is each table data would be stored in a separate directory, and the directory name is the same as the table name. So if you want to access in HDFS, you should now they have different directory. So let's see an example. So we use Sqoop import all tables. Okay, you don't need to write table name because it's all the table it would be imported, and M2 as before. So connect to the database, and the other parameters are the same as before. So another important note is if you are using the import all table, it's mandatory that every table in the database must have a primary key. This is really important. So if you use this command, as you can see, you will import all three tables in our database to HDFS. Okay. Incremental import. This is another type of import which really interesting because sometimes you don't want to import all data. Why? Because probably you have imported your tables before and now new data has been added in your traditional database. So you don't want to make this import for all data. You want to just to import the new data rows to the table. That is completely reasonable because if you want to transfer all data, so in terms of the performance, the storage, it's not reasonable. So it's completely reasonable that you just add new data. So in this case, you need to use incremental import, and for this you need to add incremental. This is the argument that you need to add to the import syntax, and you need to add another argument, check column, which means you want to say, okay, this columns needs to be checked in terms of knowing which data is new and which value. Okay, I'll give you an example. You need to add these three options to the original syntax, to the import syntax, to be able to perform the incremental import. Okay, let's have example. Let's assume that we have added a new data to the imp table in the traditional database, which is, this is the ID, name, and the other information. Okay, so we have the ID, which is the first field, is primary key. So this is the new one. So we want to only import this new data to HDFS, not all data, because we have imported the previous one before. Okay, so what we need to write is this. We write sqoop direct. This is the syntax for import. So of course, connect, connect to the database, and login information. Okay, we want the number of tasks is just one, because it's a small data that we want to import. You don't need to have more than one map task. So this is incremental append. Why we use append? Because we have an existing file and we want to add it at the end of the file. So which column needs to be checked? ID. So the first field was ID, which is the primary key. We want to check ID, and the last value was 1205. This is the last value for ID. So it said this is the last value, and this new data, any data after this value should be added to the HDFS, should be imported to HDFS. So hope it makes sense. If you have any question, of course, you can ask your question through email or chat. Okay. Now we know important syntax for importing data. Now in this step, we want to verify import data in HDFS. We want to make sure that our data has been imported properly. So this is the command that you can use to verify your imported data from imp table to HDFS imp directory, because as I said, each table that you transfer go to a separate directory with the name of the table. So this is how you can check it. HDFS DFS cat imp part m. You will go to the imp directory and check the different part of imported. If you use this command, you can see the modify or new added row from imp table. So like when you are using the incremental import. This is the one way. You can type it in the CMD and of course see the information. And another way to see your imported data is just go to data node using web UI user interface, and of course you can see it, and you know how to do it because you had enough information about this in the previous lecture. Let's see how a Sqoop export works. Now we want to export data back from HDFS to a traditional database. Here's the syntax that we need to use. You can use a Sqoop export. A Sqoop export. It can be used by a space between Sqoop and export. You can use a space or dash. It's the same. And you will have generic arguments similar to what we have in Sqoop export command, and we have export arguments that I explain you through an example. So what is really important, there are a few points that you need to pay attention. The first one is when you want to transfer data from HDFS to traditional database, it's really important to make sure the destination table is available. This table exists. It's really important, otherwise you cannot make it. So this is the first important thing. Another thing is that, as I explained before, when you have a, HDFS file, you will have records, and on the other side you will have row. So now you want to have these records as row in table. So it's really important that records in the HDFS file has delimiters to separate each element in the record, because these records would be as row in table, and these elements in each record would be as field or the value of columns in table. So you have to make sure that the data, the record in the HDFS file has reasonable limiters. So otherwise, it's not possible to make this export. So the default operation to export data from HDFS to database table is insert command. So Sqoop use insert statement to add each record in a table as a row. But if it's not a new record, it's just updating existing record, what Sqoop export is doing is using just update statement. Instead of adding a new row to table, it's just replace the existing record into the database. So this is how the Sqoop export works. Let's take an example. If you remember, we had employee data in HDFS, and employee data was available through employee data file in the directory of imp. This is the directory. In directory of imp, we have a imp data file, which has our data, our imported data from imp table. Do you remember? We have this. Now we want to export this data back to traditional database. As I explained, it's mandatory that the table to be exported is available. If it's not, if there is no existing table with this name, you have to create it manually. And you have to make sure this table is present in the database. So, for example, in our case, we have to back to our database or the destination database in MySQL and see if we have any table with the name of employee, because we want to export data to employee table. If there is no any data available with this name, there is no any table available with this name, we have to create it manually. So let's see the syntax. We have a Sqoop export. So this is the table, the name of the table that we want to transfer data. The name of the table is employee, as I explained. If it doesn't exist, we have to create it manually. This is how you can connect to the database. In this case, we want to use user database again. Of course, this is the login information, and we have export directory. Export directory is the location of our HDFS file. Okay, in this case, we want to export data from imp data file, which is in imp directory. That's it. This is how you can export data from imp data file from imp data file in HDFS to employee table in traditional database in MySQL. In our case, it's MySQL. So, and now if you want to see, to verify that this export has been done correctly, you just need to simply write a query in MySQL. Select a star from employee. Then you can see the data and you can find out if it has been done correctly or not. I want to explain one of the important Sqoop component, which is called Sqoop metastore. A Sqoop metastore provides a shared metastore repository for users and developers to use this shared repository for collaboration between ourselves. So what is happening is metastore store a Sqoop job information in this place, and everyone from each node in the cluster can access to this place. This means if a user or developer define a job, for example, create a job, for example, to load information, to load the specific data, uh, uh, to make some change, anything, this job would be stored in this place. And the other users from any node in the clusters can access to this job. They don't need to define the job again. They can simply run it. And it's really important in terms of the storage, in terms of the performance, speed. So this is what metastore is doing. Here you can see the syntax. So we are not going into details for this component. I'm going to just introduce this component to you because it's not our focus. But as you can see, the syntax is like a Sqoop metastore. You can use with a space or dash. And we have a set of generic arguments, and second part is metastore arguments. Okay, so just let you know how it works. If you run a Sqoop metastore command on your machine, you will have a shared HSQL DB database on their machine. And of course, this would be a shared place to create job, use jobs, and the other users, other clients can access to this location, to this shared repository to collaborate with others. So if a client wants to connect to the metastore, they have to use this. You have to specify and use this URL to connect, or they can use meta connect with the value of this. And of course, they need to write the server name and the port. The port can be controlled by a Sqoop metastore server port. And there are information in conf Sqoop site XML to know what is the metastore location. For example, it would be in this property, Sqoop metastore server location, and other information can be found. So of course, the metastore would be available on TCP/IP. So, and as I said, if you want to connect, you need to know the server name and the port would be controlled by Sqoop metastore server.port. So this is about metastore. The reason of having these two slides of metastore is just to get you familiar with these important components, and we don't need we are not having any practical exercise on metastore. Another useful component of Apache Sqoop is Sqoop merge. Sqoop merge provides a tool to combine two datasets into one dataset. This is a good tool for incremental import. As in incremental import, we will have a newer dataset and we will have an older dataset. And so we want to merge these two into one dataset. Here you can see the syntax of a Sqoop merge. As you can see here, we write Sqoop merge. It can be used by a space or dash, and there we will have generic argument and merge arguments. In this table, you can see some of the important parameters for merge arguments. One of the important ones is merge key. This is specify the name of the column that the merge should be done based on that. New data specify the directory of new year dataset, and onto specify the directory of older datasets. And of course, the target directory specify the final directory, the directory of final dataset. So here you can see an example, a simple example. As you can see, we will write a Sqoop merge, and this is you have to replace it with the directory of new year dataset, and this would be the directory of the older dataset, and of course it should be the directory of final dataset. This is just the general information about the Sqoop merge. We have more useful Sqoop components like Sqoop list databases here, which list the existing databases on a server, or a Sqoop list tables, which lists the existing tables in a database. A Sqoop job, which enable you to create a job or work with existing jobs, but it's really important, as you know, of course, remember to now how you have to specify a job and how you have to connect to the repository and invoke the job. So we have a Sqoop create hive table, which enable you to create a hive warehouse. And if you want to have more information about the Sqoop tools, you can go to this reference and get more information. As a summary, in this lecture, I introduce Apache Sqoop and I explain why we need to use a Sqoop. We learned how to use import and export commands for transferring data between traditional database and HDFS. And I discussed advanced Sqoop commands like metastore and merge. In the practical session, we will use Cloudera to work with import and export commands. Thank you so much for watching this video.